fantastic introduction. I'm super excited to be here. Last night I did take a walk through the campus, and I haven't been back really on the other side of the highway since 2003. So it was really fun to see some of the different things and some of the things that are still the same. So Beth did a fantastic summary of what my trajectory has been since I left Georgia Tech. One detail that was kind of fun is when I was here, I actually got a certificate in film studies, which I think it speaks to that when you have the opportunity to learn something you've always wanted to do it, take that opportunity. And then I went to Carnegie Mellon, where I was co-advised by two former techers, so Jen Mankoff and then also Scott Hudson. And then since I came to UMBC, I founded the Prototyping and Design Lab, which I lovingly refer to as the PAD. And you'll see that logo a few times in the slides, so just to explain that. So, who am I? So oftentimes it's very easy to say that I'm just an accessibility researcher, but I like to be a little bit more specific and say I'm someone who develops technology that works smoothly with human behavior. And I feel that the only way that I can do this is really think about humans in terms of their habits and their preferences and abilities. One difference that I see with myself versus other accessibility researchers, or sometimes the way people think about accessibility, is people will only focus on ability. And you'll see a lot of technologies that are built purely based on matching someone's ability, but will often ignore some of these other really, really important human characteristics. So how do I actually do this? Well, since I am an HCC researcher, the core for me is collaborating with my end users. Here's a picture of my most senior PhD student, Michelle, who's designing a wearable computer with a woman who has a visual impairment. And this was representative of a multi-month focus group that Michelle was doing with this population, where they were really engaged in designing different kinds of technologies and trying it out, trying this high-tech clipboard on a string. And the other thing is, again, since users' habits, preferences, and abilities change over time, I feel it's really important to engage in long-term interactions with my population. And I typically do this through longitudinal fieldwork. This is something that I started doing in graduate school, wherein I would spend several hours a week working at UCP Pittsburgh, and both volunteering and running my research studies there. Since this was so valuable for me as I transitioned from being a graduate student to being a faculty member, this is something that I make all of my students do, where they spend significant time working with their target populations in the field. And this can take many forms. I think the most extreme is my PhD student, Patrick Carrington, who did a clinical internship in a gym for individuals with spinal cord injury, where he was literally paid $8 an hour to wipe down benches and hang out. So today I want to talk about one theme of research that I've been working on since I started at UMBC, and it's really exciting and important to me. And that's looking at the both opportunities and challenges that this DIY and maker movement can play for solving accessibility challenges. So I'm going to talk about a lot of different parts in this talk. I'm going to start by giving kind of a brief introduction to what I mean by both assistive technology and the DIY movement, and the relevance that I see it playing for assistive technologies. And then I'm going to specifically talk about my research that we've done, kind of understanding the potential for this technology to impact users, a couple studies that we've done, and then some technologies we've developed. So I feel as though I don't really need a slide describing assistive technology for this audience, but the reason I've left this in here is I want you to know that I take a very broad definition of assistive technology, borrowing from the US Access Board, where to me assistive technology means anything from a high-tech power wheelchair to eyeglasses to duct tape that you put on a water bottle to make a handle. So assistive technology is able to empower lots of individuals to do things that they might want to do but might have difficulty doing. So this sounds great, right? Problem solved. We can end early. We can hang out, eat our cookies together, chat, right? There's no challenge here. Assistive technologies made everything great. Sadly, no. Thank you, Keith. But unfortunately, there is a challenge. So even though there's a large amount of assistive technologies that are out there that can help individuals overcome any kind of challenge, ability-based challenge they might have, a lot of these technologies actually have a really high abandonment rate. And so for those of you who are interested in this, you'll see this in disability studies. People are actually looking at why are people leaving these assistive technologies that totally solve their functional challenges? Why are they leaving them on the shelves? Why are they leaving them at home? Why is there still a problem? And I really like this overview by Phillips and Zhao, which says some of the main problems are not considering user opinion in selection, how easy or difficult it is for an individual to actually obtain the device. Unfortunately, a lot of this technology is classified as medical devices, which means insurance gets involved, which means you need to get a prescription for it, and it can take as long as a year for an individual to get the assistive technology they need. Unfortunately, not all of these devices are great, right? Even technically, they don't actually do all the things they want, or there can be challenges there. And the other thing is that our habits, preferences, and abilities can change. And also our priorities and what we really need to do can change over time. And so these are some of the really key factors we see with these high abandonment rates. And I believe that doing it yourself can offer users control that could then actually impact these abandonment rates. So when someone gets a piece of assistive technology, they would be able to use it. So I want to call out that this idea of DIY and accessibility and assistive technology is by no means new. A couple of my favorite books in this space involve David Warner's Disabled Village Children, that tells you how you can take a bucket, melt it down, and reuse the plastic to make all different kinds of casts and crutches. Or Therese Wilcom, who's known as the MacGyver of assistive technology, talks about all the clever ways that you can use off-the-shelf materials you would find at, Office Depot, and make different kinds of objects accessible to you. There's also a lot of historical evidence that humans have been repurposing objects for accessibility, where we see people making different kinds of prosthetics in the Civil War. We see people taking sticks and branches and making crutches and canes and splints, or even using animal horns for amplification. And this literature, in my experience, can highlight a lot of these really concrete benefits to people making something instead of buying the products themselves. And I want to highlight some of those really key benefits for making it yourself versus buying it in the next few slides. So the first one is that doing it yourself can be faster. And I've made this argument in a previous paper where I walk through the stages of technology adoption and talk about the trade-offs in making something yourself in our current ecosystem of maker culture versus buying something off the shelf. And some of the key pieces are that we now have fast access to information. We can have fast turnaround where we can actually make things pretty quickly. We can then customize and change those things as our needs change. And we can also now test stuff at home. Other benefit is doing yourself is often less expensive. So here are two examples of cup holders that could attach to a wheelchair. The commercial product costs $110, and online you can find a great tutorial for how you can make this out of materials from Home Depot for about $2. Doing it yourself is customizable, right? When you're intentionally designing every piece, you can then make it work or fit and look exactly the way you want. I really like this example of this 3D printed exoskeleton for a girl who has limited strength in her arms. And the idea is that her therapist will just keep reprinting this for her as she needs it, and it can grow with her as she needs it. And the final point that I think is really important is that doing it yourself can be really empowering, right? The ability to solve a problem yourself without relying on someone else can build confidence. This idea of taking control, particularly when we're talking about accessibility issues where a lot of individuals do not feel empowered, I think is really important. And of course, this goes towards this idea of helping people foster independence. So I want you to take all of those ideas and think about how it can and apply to this recent culture of DIY that we're seeing, this explosion of maker fairs where 50,000 people will show up over a weekend and show off their different events. I know on the Skiles Walkway there was the maker fair that you guys have here. And we're seeing this idea of valuing things that people are making instead of commercial products through Etsy or Martha Stewart and lots of other places. And this is so popular that doing it yourself is actually now cool. Right? I mean, think about it, not too long ago, there was that value for the store products, right? And this is very, very different from the idea of brand name devices that you purchase. I mean, I know certain people, and there are lots of communities where it's actually not cool if you bought the thing pre-made. It's only cool if you made it yourself. I think this is really, really interesting and has a lot of opportunities. All right. So in the rest of this talk, I'm going to be sharing my vision for how this can, again, relate to accessibility. And my goal really is that it can ultimately increase adoption rates. So I'm going to talk a little bit about some of the prototyping tools and online communities that have developed in, let's say, the past 10 years that I think are really, really important tools for us to be able to get closer to this vision. So when we traditionally talk about making, or if I had given this talk 15 years ago, these might be the kinds of tools that you would think about. However, I think it's really important to realize that these tools require many physical requirements about their users and make a lot of assumptions, often the ability to stand, precise manual dexterity, and accurate vision. And as a result, these can really limit who can actually operate these machines. And as a result, these machines can be very dangerous. I would probably not recommend to somebody who has Parkinson's that they should be using a bandsaw, right? Now contrast this to this new generation of affordable and rapid prototyping tools that are specifically designed to empower people who do not have special training with those kinds of tools to be able to make one-of-a-kind objects. What I think is really exciting about these new tools is they're computer controlled. So now when we talk about the barriers to using these, it's less about physical dexterity and visual ability, but it more becomes a computer access problem. And coming at accessibility as a former computer access specialist, that's what my dissertation was on, I said, oh great, we totally know a lot about computer access. We're now changing this conversation where it's now a completely different set of challenges. Okay, so there's lots of different kinds of tools that can make lots of different physical objects. I know Georgia Tech has fantastic facilities to make lots of different things. At this point, I just want to focus, most of my work is on 3D printing rather than laser cutting and CNC mills. And that's because I see 3D printing as the most accessible of these in terms of actually interacting with it and getting the object. So I just kind of wanted to put that in there, but I'm happy to talk about opportunities for these other technologies later on. All right, so we have these tools that are accessible, and we're actually now starting to see access to them, availability, right? For fewer than $500, you can go on Amazon Prime now, probably have it delivered later this afternoon, depending on where your distribution center is, and you could have a 3D printer of your own that's pretty good and pretty powerful. Or if you can't afford one of your own, or you don't want to have one in your house, there are lots of opportunities for you to go to a local shop, or we're even seeing a lot of services develop where you can send them a file and they will mail you a physical object. The other important thing that's changed here is we're seeing online communities becoming very important, where we're seeing people share their designs, things that they've modified, people sharing their experience, knowledge, and even inspiration online. And I think two of the most important communities for this is the Instructables community and then Thingiverse. And I'm going to be talking about Thingiverse a lot more in my next section. Okay. So over the past 4.5 years, I've been really focusing my efforts to understand the challenges and opportunities of this new ecosystem and how it can relate to do-it-yourself for accessibility. And since a lot of kind of rapid prototyping, when we talked about that maybe 15 years ago, we'd typically be talking about something that would be happening in like a mechanical engineering department with machines that were tens of thousands of dollars. And I'm really excited that this technology has now been democratized to much more diverse populations. And I'm really interested in understanding how novices, people who do not have engineering backgrounds, approach this technology and what they would want to use with this. So to this end, I've conducted a lot of different interviews at a lot of different sites with a lot of different individuals, and also engaged in a lot of studies around cultural probes, where we might put a piece of technology or a faux piece of technology there and get them to talk about how they might use it or study how they might use it. And we've done this in different contexts. We've done this in the home, done a lot of work in special education, and then I've done a lot of interviews and work with people who traditionally, who have disabilities and use assistive technologies. And from all of this, I've identified a set of opportunities for DIY and accessibility that I want to call out. So the first one is, I think, really important, and one that I really expected to find, is that there's a lot of opportunity to build objects. Again, I focus on 3D printing, so things that are made out of plastic that can be used as different kinds of assistive technologies. And making these, it does turn out to be less expensive than buying something off the shelf. And when we think about stakeholders here, most of this has to do with working with therapists, and actually really nicely supports what a lot of physical, occupational, and rehab therapists are already doing in their jobs. So I wanted to call out this story that we saw when we were working in a school for a special education school, where we're working with physical therapists and occupational therapists, and they had a student who wanted to be able to access an iPad with a stylus. And they had bought her a whole bunch of different kinds of styli, and none of them fit. So they did what probably most of us would do. You go to the store and you buy all those little things that make it soft and grippy to hold it. None of those worked either. So they'd actually kind of given up on giving the student access to an iPad. So we came in as we tried to figure out how we could make something that would be 3D printed to solve this challenge. What we ended up doing was we gave the therapist some clay, and during that student's weekly session, the student pinched the piece of clay in a way that was very comfortable to her unique hand positioning. We then took that clay, 3D scanned it, poked a hole through it, and then gave it to the therapist, and we created this kind of model. And the great thing is, this worked, right? So after several months or maybe a year and a lot of money, we were able to find a unique solution that worked really well for the student. And this story is just one of many that I've encountered over the past few years, but I think it really highlights the opportunities for this technology. One opportunity that I wasn't necessarily expecting when I started out on this adventure was that 3D printing and making custom objects can really support multimodal learning, and we can make abstract concepts very tangible. And I think this has a lot of opportunities for people. When I first did this, we were thinking, oh, this will be great for people with vision impairments, right? We can make abstract things tactile, we can provide tactile visualizations. But as we got deeper, we realized that when you think about different kinds of learning styles, there are a lot of people who can learn, they're visual learners or audio learners, and then there's people, if they're able to hold it, they're able to understand it much better. So I have some examples here of Hurricane Sandy, and then also I think this has interesting ideas when you think about a clinical setting. If you're able to give somebody a model of their body part and be able to talk to them specifically about an injury that's happened or where they are in the rehabilitation process, this can make it much more tangible. So rather than just producing useful pieces of plastic, I think it's also really important to call out that this can offer a lot of opportunities for individuals to learn high-tech skills that are relevant for many areas of deployment. So individuals across all of the different groups identified concrete educational benefits to learning these tools and solving accessibility challenges. And I think this is really important, again, when we think about traditional education for students who use assistive technology. Oftentimes they're not steered towards STEM, and a lot of the employment opportunities they have are not highly technical. And I think there's a real opportunity here if we're able to train them and teach them early how to solve their own accessibility challenges using this technology. They could learn really, really valuable, employable skills. And I've been pushing on this area in lots of different ways. I think perhaps the smartest one is I've lent, kind of a long-term loan, several schools 3D printers, and then I've had students there provide support to instructors and therapists on how to use those printers, so we can really understand how you would develop curriculums for how to do this, and you can start to see some of the benefits. And I would say, in general, this dovetails really nicely with the larger maker education initiative that's happening. But so far, we're the only ones who are really thinking about this in special education. Okay, so the other interesting thing that we've learned is that making can solve problems and also maybe void warranties. And I think this is a really interesting point to call out, and something a lot of people ask me when I say, oh, we do it-yourself assistive technology, and they're like, well, those wheelchairs, right? Those are $30,000 machines that have payment and maintenance plans. Like, you're not going to be able to change any of those things, or what happens if you void your warranty? And so my favorite story to this question came out in an interview that I was doing with individuals who are power wheelchair users. And they were willing to make, most of them were willing to make modifications to their power wheelchair so long as it didn't void the warranty. They were very aware of warranties and service plans because they use these service plans when you're out in the streets with like snow and salt and potholes. Like, you really care that your wheelchair is working. But they wanted to be involved in the design process. And what I thought was really interesting was a lot of them were actually willing to void their warranty so long as they knew what was happening. Like, they did not feel comfortable with somebody else voiding their warranty. But if they were really involved and they knew what happened, they could explain it, they could fix it, they were okay with this. And when I pushed a little bit further, it really hit home the story from one of my participants who said, when it breaks, I stay in bed. And he talked about how his power wheelchair was broken, and he spent 2 months in bed, unable to leave the house because he was waiting for the service plan to kick in and a technician to come out and get the part. And so when you really think about that, that issue of empowerment really comes in. You really see the opportunities for people to really change their quality of life by being involved in this. Okay, so this sounds great, right? I've given you a lot of theory, I've given you a few stories, but what are people really making? Well, over the summer, we sought to get a better sense of this by studying this online community called Thingiverse. And we wanted to know what kinds of assistive technology had been posted, who made it, and figure out a little bit more about why they were making it. So for those of you who don't know or aren't familiar, Thingiverse is an online community geared towards making, and it requires users to share their designs. Uploading a finished photo of, look, I made this, isn't enough. And I think this is one of the key differences between Thingiverse and Instructables. This website's existed since 2008, and as of 2013, they hit their 100,000 design files mark. I haven't been able to figure out how many new files are on there, but it's a large set of designs. And I think this website is really interesting because a lot of it is leading this open source hardware movement of the idea of people sharing design files, plans, and experience in making physical objects. So I also kind of think of this or explain it to people as GitHub, but for physical objects. I know GitHub now has like their 3D model files. I'm happy to answer questions about that and talk about how this is different. The other thing that I think is great about Thingiverse is it's really a community. It encourages people to share experiences, failures, questions, make recommendations, fork designs, and make different kinds of variations. There's really a lot going on here. So we did a survey. We had a whole bunch of people doing probing this database to figure out what kinds of assistive technology was there. We created a large set of almost 200 terms of things that we felt represented assistive technology. We got a bunch of designs from that and then culled them in things that were actually assistive technology. And up here, I'm showing numbers of the different kinds of things that we saw in terms of assistive technology. But I want to ask the audience, does anybody want to guess how many of these designs were actually assistive technology? So there's over 100,000 things that are shared on Thingiverse, right? I've motivated this thing. I have probably most of you convinced that there's a lot of opportunities here for 3D printing assistive technology. Raise your hand if you think there were like 10,000 pieces of assistive technology. Note, my assistive technology definition includes medication management, so like pill boxes, or prosthetic limbs, like everybody's heard about probably some kind of prosthetic limb that's been 3D printed. Or even just replicating stuff that's that expensive stuff that's in the catalog.
Are you going to go up or down from 10,000?
That's a great question. Which way do you want me to go? All right, I'm going to go down from 10,000. 5,000. Anyone? Okay. 1,000. 500. So we found 360 things that actually...
You didn't give us a chance to vote.
You're right, you're right. You were going for 100. All right, that's an important data point. Well, if you actually fit in things that are traditional assistive technologies, that number really is in there. And that was really shocking to us. We had suspicions because we've been monitoring this. I do a lot of events where we show the applications of 3D printing and assistive technology. But to really go through this was really illuminating for what's really happening in this community. All right, so 363 designs. Of those designs, we went through and we categorized them in a lot of different ways and studied what they were, and details about that are in our upcoming Chi paper. But one metric that I thought was really interesting was looking at construction complexity. So almost a third of these were a single part that could be 3D printed. I'll also go through and talk about some more complex things that could be 3D printed or laser cut. But what's interesting about the single print is I would make the argument those are the most accessible to people, because that is exactly the epitome of the computer access problem, where I'm able to go to my computer, I'm able to print out this file, it prints on the machine. The only physical task I need to do now is taking it out of the machine and it's ready to go. So I thought that was actually pretty promising that we saw a lot of those, but also noticed there were a lot of them that were really complex. Maybe you have multiple parts, and once you have multiple parts, there's issues of assembly, or there was roughly another third that was 3D printed parts and then stuff you needed to go to the store for. So this is really cool. It's a great way to get flexibility, but I would make the case that those other two are probably less accessible than the 3D printed part. Really the holy grail here is that thing that you can just print, grab it out of the machine, and then use it. We also did kind of a popularity assessment. Thingiverse has lots of different ways to kind of measure popularity, including just liking a thing. You can actually talk about, okay, I downloaded this thing, and then you can submit photos and say, I made one, so we counted those. We also looked at the number of designs that people had posted, and then other people had remixed it or forked it. And so I think an interesting thing here is that the two most common or most popular things were 3D printed hands and then toys that had Braille on them. And so that was really interesting to us in terms of what things on this website are really popular. Again, were not the things that we were expecting, the really traditional assistive technologies. So I want to reflect a little on what we've seen and what we can take away from this work. The first thing is that DIY still can take a while. It can still be a lot faster than buying things through the traditional methods. I'm going to go back to the story about the student who had the grip for the iPad stylus. This took us about 6 months to get right. And the reason was this student only had an hour time with the physical and occupational therapist once a week. And they had a lot of other things to do than this. So squeezing time and finding the time to make this happen is quite challenging. The other thing is physical therapists and occupational therapists have full-time jobs, right? And learning all of this new technology is not currently on their list of things that they have to do, even when they have access to the technology. Another point I wanted to make here is that it can take a while, but I think we're really on the right path. So we made this stylus, and of course we triumphantly returned to the therapy session to say, look, we have produced an object and we have solved the problems. Look, real world impact. And the therapist looked at that and they were like, well, that's not going to work. She has a different stylus now. But it was okay because we had the 3D file. So we were a little saddened, but we went back to the lab, we poked a bigger hole in it, and then brought it back, and it fit. But it's really important to account for this amount of time that people can really spend doing these kinds of activities. Another important point that we've learned is it's really important to choose the right equipment. There are a lot of different kinds of 3D printers that are out there on the market. It's really important to choose the right kind of technology for the right setting. This is my favorite example. This was from a school for students with visual impairments. And this was a very expensive, like $20,000 3D printer that was donated to the school along with, a year's long of supplies of materials. Do people have thoughts on this printer suitable for a school with people with vision impairments? Right, a full color printer that creates very delicate objects that you cannot drop on the ground, otherwise they'll shatter. The other thing is, in here the print bed represents everything that's ever been printed on that printer over a year. Right, so when you have the wrong technology, also this technology was of course very expensive, so it was put away in a locked room where there was one overworked technician who had access to it. Right, so again, you really need to think through how do you integrate this technology so you can have the right opportunities. I'm happy to say the school is now integrating this technology into classrooms, and I'm hopeful to hear new stories about how this is really being used, because there are a lot of opportunities in this space. The other thing is there's a really steep learning curve to learning this design software. Even though we're seeing Tinkercad, SketchUp, whatever cool new Autodesk software coming out, these things still take a lot of time to learn, and time that not everybody has because they have busy lives. And then the final thing that I want to call out is about designer experience and motivation. And I want to go back to the Thingiverse study. And so we had those 363 objects. Those were made by 273 different designers. We conducted an online survey and had 69 of them respond, and we wanted to understand why did they make these objects and who did they make it for. And we were really surprised that very few of them actually had a disability. I think it was, I don't remember now the numbers, maybe 10%. And this is also using a very liberal definition of this, where we included medication users, so anybody who takes medication according to a rubric would count. And also very few of them had any kind of assistive technology training. The majority of the items that are on Thingiverse that we count as assistive technology are made by people with STEM backgrounds, and they were either making these designs for someone they knew or someone they had never met, or someone who might not even exist. I was really interested in people who were doing this because they thought it would be an interesting design challenge or just for a class project. And I think these findings really beg some interesting questions about the current state of DIY AT. So I'm still playing with the right wording, but instead of doing it for yourself, I'm seeing a lot of trends of doing it for somebody else, which I think still has these benefits of being fast, less expensive, and more customizable than buying things off the shelf. However, is this really empowering to this population who's going to use these? I think it's really important that we consider support issues and maintenance, and think about what happens to these assistive technologies as users' preferences, habits, and abilities change. Again, going back to the abandonment rate issues that we talked about with traditional models of assistive technology, I can see us quickly going into a situation where everybody has these unique, beautiful pieces of assistive technology that nobody knows how to fix, nobody knows what to do with, and it might even be worse than our current system where we have support models and standardization. And I think this is really interesting and the real next challenge in this space. And I want to call out, so I'm not saying that engineers and technologists lending their skills to assistive technology is unwelcome or not valuable. Instead, I see this as a big challenge of how do we actually diversify the pool of designers and create more opportunities for individuals with disabilities or assistive technology users to self-design and further be incorporated in this maker movement. And so I'm really now focusing a lot of effort in looking at how we can create accessible modeling tools so we can diversify this population. And I have this concept of effortless 3D modeling. Let's see, and a lot of what I'm doing is different, again, from these open sandbox tools like Tinkercad or SketchUp. Instead, what we're doing is very, very focused to help a user get in and get out and get the thing that they need. So I'm going to talk about two examples that I've done in this space. The first one is VizTouch, which is software that can automatically generate tactile graphics for tactile learners. So traditionally, tactile graphics actually have a really long DIY history of people using puff paint and glue and glitter to make visualizations that are tangible. There's also a large number of tools that you can buy and even get different kinds of embossers. However, these either take a lot of time to make or are really expensive. And so when you have a classroom or a situation where somebody would actually want a tactile graphic, they usually don't have it because nobody's pre-planned or put together the effort or even have access to the tools to make it. So what we did is we created this software called VizTouch that it can allow users to easily create these tactile graphics where you can simply upload a spreadsheet or enter in an equation. And the above is the simple VizTouch interface. This may look very familiar to you as just another form, right? Like this is not a scary 3D modeling tool that you may feel that you need an engineering degree to interact with. And I think what's really cool about this is you just interact with that form and then it'll automatically create a customized 3D model that's ready to be printed. In this example of the equation, it takes about a minute to generate that file and then about an hour to print on a machine. So that's an example for equation output, and then this is taking a spreadsheet. And the cool thing here is we can, of course, customize all sorts of things where we can use standardized Braille if you're a Braille reader, or we can use non-standardized Braille. These are real opportunities of things that you can go beyond traditional embossers. The other example I quickly want to talk about comes back to that grip for the stylus user, where we're really inspired and we're thinking hard about the problem where we made the stylus and then it didn't fit. We made the stylus holder and it didn't fit. So we created this tool that we call GripFab to automatically generate these hand grips. And we think this is a tool that could be used by therapists, teachers, students, or anybody else who might like some help holding an object. So again, very simple form-based tool where you just enter in measurements and parameters, and it's very flexible and we're able to make a lot of different kinds of things. So this is the stylus grip that I was talking about. Here's the same kind of grip but at a different angle for a different activity. Here we can customize the hole so it could fit a fork, or we've also been exploring different kinds of grips, thinking, well, does it really need to be, do we really need to do the thing with the clay and scanning for your hand? Or are there more kinds of categories of different kinds of grips that would be useful? And so we're exploring this actually in an art classroom where they have a wide diversity of objects that people want to hold. So what's next? A lot of the things that I'm interested in is then studying the impact of these tools with diverse populations and really understanding how different stakeholders might use them. And of course, I'm really interested in continuing to study the evolution of the do-it-yourself and maker movement culture in relation to assistive technology. So I wanted to mention, when I came to UMBC, I created this laboratory called the Prototyping and Design Lab, and we do lots of other projects where we're looking at subjective question and answers on social media to visual questions, rethinking blind navigation. We have a project with power wheelchair users called Charitable Computing that's secretly codenamed Pimp My Ride. Looking at DIY.
No longer so secret.
It's been published, it's fine. We have several papers. And then also continuing my dissertation work on adaptive user interface. And in the pad, for whatever reason, we have kind of a tradition of naming things. So our room is called the launch pad, so everything is very space-based. All of our printers are named after Star Trek ships. for some reason. And so we also have this notion of captains. So on the left are all of my different PhD students who are working in this space. And then we have 2 fantastic postdocs who are also collaborating us with the pad. And each of them has their own fleet of people who are working. And then the final thing I want to say is that I feel that in order to be someone who studies maker culture, it's really important that I myself am immersed in it. So I really, eat a lot of my own dog food, and we go to maker fairs, we go to pretty much every maker event in Baltimore, and we're engaging with people and sharing what we're doing and getting inspiration. And so with that, I would like to thank you all for listening to my talk. I also thank all of my students, collaborators, participants, and supporters, both at UMBC and across the US. And of course, thank you to my funders. So I'm happy to answer any questions that anyone may have on anything. Gregory.
So a lot of these 3D printers now come with multiple heads or nozzles, so you can mix a different variety of materials,
Sure.
and you can do more than just the
Yep.
hard plastic.
Uh-huh.
So what do you think are the opportunities for doing that?
There's a ton of opportunities. I think one of the biggest ones is the soft 3D printing. In the grips, we've done a lot with kind of rubberizing it with foam and whatever, but I think the real sweet spot in the space is it comes out of the printer and it's ready to go. So Ninja Flex is my favorite product of choice for this. And we're playing with that, and that is a really flexible material. I think there's also a lot of opportunities for prints that have multiple components. So if you're able to use a rigid and a soft material, that really opens up the set of what you can make in a single print. There's also these really exotic filaments that are coming out that are wood, brick, sand, conductive materials, light reactive materials. All of this is, I think, huge opportunities. Unfortunately, the machines are not as robust at printing exotic materials as we would like. And I think there's kind of that, more extruders, more problems. I think one of the biggest challenges with 3D printers is actually their reliability. It's not their cost. You can buy a printer for a few $100s. How reliable is it really going to be? How many times are you going to come in a few hours later and have a big pile of spaghetti and a failed print? There's lots of jams and other problems with it. So the technology isn't quite there. Whenever we deploy a printer into a real life setting, we always use the most reliable and simple printers just because we don't want to add extra technical challenges. However, I have faith in the material engineers that they will solve this, and then we'll be able to print even more exotic and interesting things. But for right now, we're just doing what's simple and reliable. The other thing is filament comes in lots of different colors. I think the best one to actually print with is like a neutral or a white because people love to color it, right? You can just color it with a Sharpie or nail polish or whatever else, and that's a lot easier than trying to get exactly the shade of pink that someone wants. Yeah, Ed.
So I agree strongly with you that, this is a way to get people on our ingredient solutions for them.
Mm-hmm.
And that, it is a side benefit of employment for adults. And for kids, it's a good STEM education opportunity.
Yeah.
But a lot of assistive technology is for aging.
Mm-hmm.
And these tools are not easy enough to use for aging adults. What do you see as a possible solution there?
That's a fantastic question, and I keep trying to get one of my printers and some of my students into an assisted living or independent living community to really explore that. I've done several focus groups with older adults, and I even taught a class that was specifically 3D printing for older adults where the students went and worked with a specific center, found people, made things for them. I even did a summer in a library that's connected to a senior center, and we made things. And I wouldn't underestimate older adults, just like any other population, and I believe the grip stuff is the piece of technology that's one of the next things that we want to work with them. And again, it comes into a lot of older adults are actually quite busy, right? And so a lot of the requirements that we would see for therapists are very broadly useful to diverse populations and people who'd want to make stuff. There's a ton of opportunities, and I'm looking at it, and I would love to collaborate with more people because we've done a lot, but we've never actually done quite enough to publish any of that. Yeah, but it's a great point. Yes?
There have been some discussions of the homogeneity of maker spaces and how that can be very exclusive.
Uh-huh.
Do you think that maybe that is contributing to the problem? And how do you think that can be addressed in terms of getting, since it's your specialty, including people with disabilities in these spaces, but also in not devaluing the work that's already being done, because in a lot of ways, people are, there's a dichotomy created between, I guess, making and like DIY hacks that fit into like these types of categories, and other things that people are making that are maybe more low tech, but just as practical solutions.
So this is a fantastic question. So as somebody who's been a member of many hackerspaces over the years, I know exactly what you're talking about. And I mean, I think it's a really interesting challenge. And I would first look to the larger maker movement, which is really trying to diversify this term maker. We're seeing lots of, my favorite actually is from a local organization in Baltimore called Digital Harbor Foundation. And they teach kind of like making skills to inner city Baltimore youth. And they have a group called the Makerettes. And I love this, and it's specifically focused on engaging girls, females, in making. And so I would kind of look to a lot of that. But there's an interesting question that we see with any technology, and it even goes back to programming, where how do we diversify a computer science pool? Do we have separate groups for different populations, or do we try and change one larger group to be more inclusive? As being involved in running makerspaces, changing a makerspace is very difficult, but I think it's very important for them to be open. What I've been focusing on in my work, though, is looking at how we can integrate it into schools and places, how we can integrate this technology in places where this population already is. But I think that's a really valuable question and something to look at. Yeah, but it's a problem a lot of special tech areas have. Yes?
I was wondering about, depending on what you're making, some of these devices have some medical implications. I was happy to see that you were working with the therapist when you were working at the school, but for some people, if they're doing this on their own, they don't have those supports.
Yes.
And one thing that had me nervous, one of your earliest slides, you were showing a head pointer, which is great for some people. Sometimes that's their only way of accessing material, but there's also a high correlation with neck problems as a result.
Yeah.
So how do you feed that expertise into this
That's
process?
such a great question. And I'm actually going to go back to this idea of DIY is not new, right? And so particularly people coming up with creative solutions for them to do the things they want to do has been happening for decades. And then there's that question of, is this safe? Is this the right thing or not? And so we have a new tool to do some of those same behaviors. And so there's interesting questions, I think, of how people are going to engage with that. But I would first call that out, that people have been making head pointers out of duct tape. And so that first example I showed had no 3D printed parts at all. And that was in some of my first work of trying to understand within some of these centers, what are the assistive technologies that people are making. That involved instructors, but who were not clinicians. I think the online communities part can play a large role here, where people could engage in different kind of communities where clinicians might be participating, and they could evaluate devices, and give interesting feedback or answer questions. You could also imagine Thingiverse having some kind of category or recognition that this device is clinician approved for people within this specific category. But I mean, again, you have these assistive technology catalogs that anybody can buy anything, and so how do you regulate that is a really interesting and complex question. The difference here is now people could print it in their home, and I think that's something worthy of investigating. We're doing a little bit of that work with where we're taking the GripFab tool and talking to different kinds of stakeholders about who should use this tool, what are some of the different risks. And so I think it's a very important question. Yeah. Yes?
Right, so I was wondering about the people you've sort of talked to. Have you seen more an interest in people taking an active role in participating in making a technology to be printed, such as the wheelchair case you mentioned, or does the general population lean more towards just going on Thingiverse and clicking print?
Another great question. I will answer that like any good question you ask any HCC researcher. It depends, right? Again, it comes back to personality, right? Where some people are just, they love making, they love this idea of being able to change things, make physical objects. It really comes from empowerment. Other people, they don't care if you made it or it came from a store. So I've seen all of it. And I think that's a really interesting question of how do we empower the makers and people who have this maker spirit, and then also how do we encourage people, I don't know, they're the buyers, how do we encourage them that there's some value here and they could get something unique. That said, also, I think time is a huge issue. Even though like the tools are available, you can download this thing, not everyone's gonna do that. They're still gonna see it as easier to just go to the store and buy it or have somebody else buy it or make it for them. So it's another really interesting question. And I don't think there's going to be a universal answer. James?
So following up on that, I mean, how interesting is it to imbue the maker spirit into these populations versus just helping someone solve a problem? Is there a repeat access to using these technologies, or once I've got my stylus holder built in my lab?
Right. If I were teaching a class, I would make you answer that question yourself, because I think your question has the answer embedded in it, where it comes back to empowerment, right? Like when more and more people are seeing themselves as makers, taking control over their lives, empowering themselves, there's going to be more payoffs. Of course, there's the stylus issue, but as we quickly saw, and once we had that, then it was like, well, how is she going to use a glue stick? How is she going to use a fork or a hairbrush? Can we make this? And it can be very contagious, where when that taste of empowerment and taking control, that then people want more. And I think that's something that's very worthy of studying within this population. And I think this is something that's, again, very different from do it yourself versus do it for somebody else, right? When somebody receives an assistive technology that was made for them, they're appreciative, they're happy it solved that problem. But then there's kind of that issue, well, I don't want to go back and like ask them if they could tweak it. Right? It's kind of like, this is what it is and this is over. And the fact that when you have access to the design and the production tools, you can really customize and make it exactly the way that you want. And so I think that's a really great thing to then study, and we'll see how that goes and what are those killer apps that then are the things that help people then see themselves as makers. It's a great question. Yes? Sorry, say that last part.
Have you looked at assistive technologies for the actual process of designing and making? Like people like tactile feedback while designing, and everything is software right now. So has there been any efforts into that?
So do you mean like coming up with standards for what should these kinds of assistive technologies look like, or?
No, I mean like actual designing part, like everything is software right now.
Okay. Yes. So we've done some studies. I've had some students look at it. We haven't published any of that yet. So one of the things is, at least as of 6 months ago, it was really interesting that none of the design tools were accessible through a screen reader, even some of the text-based ones. That, I think, has now changed, but I think that's a really, really important point. And that's one of the reasons why we've been creating our own limited functionality, but very accessible design tools. Those are things that are accessible by a screen reader. They are things that are simple interfaces that would work with what any kind of computer access software that someone with any motor limitations might have. But I think that's a really important question, is are the design tools accessible, and something we're thinking a lot about. Yeah. Other questions? Oh, yes.
Not a question, but if this talk, thank you very much for presenting this. If this talk inspired anyone to fall into the doing it for someone else category, we do have a couple assistive technology resources on campus, including every state has their own technical assistance program focused on assistive technology, and this project for Georgia is on campus, Georgia Tools for Life, gatfl.org. And I'm from CATIA, the Center for Assistive Technology and Environmental Access, and